Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. Episode 20 is a conversation with Andrew Rodgers, co-founder of ACE IoT. This is a great primer on what the word open means for buildings. Open is a very controversial and murky topic. I think Andrew clears some of that up in this conversation. If we could unlock the data in our buildings and open up communication, we could do things like help mitigate climate change, create healthier indoor environments, and finally actually automate our buildings. Andrew and I talked about open myths, definitions, and walk through each layer of the smart building stack to unpack it in depth, including how we can learn from slime molds who have it all figured out. Without further ado, please enjoy Nexus Podcast episode 20. All right. Hello, Andrew. Welcome to the show. Can you introduce yourself for everyone?
Yes, I'm Andrew Rodgers. I'm a co-founder of ACE IoT Solutions. We're a software company that offers infrastructure as a service for companies who want to use an open source technology called Voltron in their smart buildings projects or systems or platforms.
Cool. All right. And we're going to get into Voltron in a little bit. Let's start, though, with your career history. How'd you get to founding ACE IoT, and what have you been up to before that?
My career has been pretty varied, pretty broad. I got started at a fairly young age in the industrial automation space, specifically industrial IT systems. At 19, I was in a triple reporting role to a plant engineering manager, plant maintenance manager, and IT manager for a 600 employee factory with about 70 connected HMI IT systems, and had to manage those and generate backup plans. And of course, they were all different vendors and they have all the same problems that this space has. So I did that for a while. I went back into kind of more general IT, back into industrial automation, a little stint in some buildings 12 years ago, and then got really involved in smart cities. And so I spent the last 5 or 6 years really deep in the smart city space, working on citywide strategy and research projects with both our local university and our local municipality. And then that's how I got introduced to Voltron, kind of met some folks through the smart city ecosystem, and then really dove into the Voltron world, helping the city of Washington, D.C. deploy and build out their infrastructure for their smart building portfolio.
Got it. Okay. Cool. And before we dive into our main topic, what is Voltron? Just like short description for people that have never heard of it before.
Voltron is a box of Legos that you can build, and sorry for the pedants out there, Lego system bricks that you can build smart and connected grid-enabled buildings, building integrations with and microgrids. It's all things distributed energy. It's not necessarily a product in the sense that we think of a lot of vendor platforms in this space. It's just a technology that can be used, and you can build a lot of other products on top of it.
Cool. And it was developed by the Pacific Northwest National Lab originally, and now it's an open source project. Is that how?
That's right. Yeah.
Okay.
It's part of the Eclipse Software Foundation now.
Cool. All right. Sweet. So what does ACE IoT do for your clients, and how do you work with your clients?
So it varies. Our primary business is a software / infrastructure as a service. We will use our cloud platform to manage Voltron instances at your customer sites, make sure they're running effectively, updated, patched, all that stuff, configuration management, and then send that data to whatever system that you're building if you're a software company or another technology company. We also do some consulting work in the sort of infrastructure space for data systems in both the smart building space and the solar energy space. And then part of that is also focused not just on what we think of as large scale commercial buildings, but other places where grid interactive building technologies are useful. So like we've got a project right now with EPRI and some of the other national labs working on some residential applications where we're using Voltron for behind the meter optimization.
Got it. Cool. All right. So this is the point of the conversation where I ask you my favorite question. Why are buildings decades behind other technology? Like the technology in our pockets and that we're talking over right now, why are buildings so far behind?
So I like to think about it in terms of the pain consumer distance. For consumer facing technology, the feedback in the market, like, people talk about the market working in all kinds of mysterious ways, but if you don't have a feedback path, the market doesn't work. Markets don't work if there's no feedback. That's when you look at things like the financial crisis in 2008, the housing, that was the problem. The feedback loop was broken, so the market wasn't actually self-regulating. When we look at consumer technologies, if someone releases a phone that is terrible, people don't buy it. And that's your feedback loop. It lasts one technology cycle. And the people who are paying for the phone are the people using the phone. And I think that's the big difference. The people paying for smart building technologies are not generally the people using the smart building technologies. And that is throughout the stack. So that's the people buying the buildings are not the people occupying the buildings. The people choosing the vendor relationships are not the people that are deploying and programming. The people who are having to do the commissioning, and the fact that commissioning needs to exist as something to bring together all these systems after they've already been deployed by their respective vendors, aren't the ones selecting or choosing the equipment that's being deployed. So the further you have that distance between who feels the pain of the choices you're making and who has to pay for the choices, I think the slower your progress is and the more sort of dystopian a reality you can end up in. I think the evidence when you posted this morning about having this conversation and got, pretty, maybe not the most feedback ever, but very fast feedback.
Right.
I think that's evidence that people know something is broken, but there isn't really change happening to affect that.
Totally. Yeah. And there's certain words that when you bring them up, people are they just jump right on them. And that's what we want to talk about today. But first, on that answer, what do you see as the ways, like in the marketplace, that you're seeing, I guess, that feedback loop get closed up?
Yeah, I think you talk about this a lot when you talk about advanced supervisory control 2.0, when people are building platforms that are reaching the tenant. I think that's an important piece. I think that the fact the tenants themselves are starting to make these demands, they're seeing that it's broken, that it doesn't work like their phone does, et cetera. I think you've had a few guests recently who are all working on platforms that are thinking about the user experience all the way out to the tenant level. I think what we're going to talk about on the open side, Mike Bruman, that conversation, they're definitely thinking about that as a user experience down the stack. And I think that perspective is what's going to move us forward. I think the old perspective of how do we have a flashy demo at AHR and get a new distributor signed up for our platform is not how you move the industry forward.
Totally. I love that answer. And I love how I'm getting different answers. So thank you for bringing some diversity to the answer of the question. Cool. So let's dive into our main topic. So Andrew, you were referencing the post I made on LinkedIn this morning. So thanks to everyone who contributed to our outline for what we're about to talk about here. But it really was this conversation about what open means really became clear to me a couple weeks ago, like how important it was, because I posted about JCI's Open Blue platform. And that post got, I want to say 120 comments, something like that. By far the most popular, most engaged with post that I've ever done. And I've done a lot of posts, and that one seemed to really strike a nerve. And for me, what it was about, I don't know what it was about for you, but for me, it seemed like a lot of the comments were debating what open means and like what the definition of it is. And I think mostly everyone was agreeing that JCI's definition is probably not it, but what is it is the question. And I think that's what I want to get to today. So with that, we have a lot to cover, and there's a lot of different ways that we could take this conversation, I think. But what I want to start with is around myths. So what are the biggest myths when it comes to the word open in our industry to you? I guess that's a good place to kick it off.
I do come at this from a little different background because I do have more of a history in the technology space. And when we talk about open in the technology space, it just has a very different meaning than what I see at least marketed as open in this space. Obviously, there is open and open ecosystem, and then there's open and open source. And I think those are key distinctive things that they're different, both in technology and in this space. But I think that the people in the technology space seem to be more well-versed in the nuance and difference between those two. And the people in this space seem to have not a lot of examples to look at of other versions of that. And I think when you talk about open, when the people that are dominant in this industry talk about open, they talk about open ecosystems, and they're worried about things like vendor distributor agreements. It's almost policy based more than practitioner or individual contributor based. Like, how does an engineer interact with this? And so I think I don't know that I would say it's a myth. I just think it's like a fog of war over the entire thing.
Yeah.
That there's just, because you have some very dominant players in the space who put out a lot of volume of content and just marketing, it's hard to find those like concrete answers. And really, open kind of comes down to an ideological position. You can say it's only open if it's in software. We talk about libre, which is like this concept of freedom of speech, like free as in speech. And then you have free, which is free as in beer. And it's interesting because like neither of those really play in this space. There's nothing free. It's just whether or not there's additional restrictions on if you can play once you pay for it, can you play with it? And I don't know that like I'm the person to say, here are the myths, like here are the things that this industry has 100% wrong. I think my perspective and what I want to bring to this is, hey, there are other industries that have gone through these transitions from closed ecosystems to open ecosystems, or more closed ecosystems to more open ecosystems. There's a lot we can learn from those transitions and transformations, but we do have to stop navel gazing. Whether Open Blue is open is a concrete answer that is going to depend on a lot of factors of what you care about. And when you say you want something to be open, but do I think that Johnson Controls is going to tell this industry what open is? No. I think if you let a company like Johnson or Siemens or any of the big vendors define that for you, the industry loses. So I think the most important thing about this whole open discussion is that people really are able to enumerate what they care about, why they're making decisions, and get beyond the marketing, honestly, regardless of how open. I mean, I think even the conversation this morning, the people contributing to the questions to ask, it was obvious that there were people coming from very different perspectives, and there were people very happy with a mostly proprietary system and calling it open and saying it solves my problems. And if it does, that's great. But I think we get back to the question of, why are buildings decades behind other tech? And no one's arguing that they're not. I see very few arguments that they're not.
Haven't had that answer yet. No one's arguing with me.
But you hear so many arguments of defending the status quo and why things should be the way they are. And I think you just have to say, okay, we've been doing this for a long time, and this is the result it's gotten. There's got to be a different way. And I think people coming to that realization on their own is going to be, and learning enough about how other industries have done this is going to be much more impactful than you or I defining, here are the rules. I do think it gets down to, what are the capabilities that are unlocked for me? And then once you say, okay, these are the capabilities I need, and this is how an open or a proprietary ecosystem solves those, or allows me to solve those for my clients, then it really can become preference. I don't think anyone's saying you cannot solve problems in a closed way. It's just that, if this is where I would lean back into the workforce discussion, because I think where these decisions get made in the stack is very different between BAS. I think we talked about the paying consumer distance. I think that on average, technology workers, specifically in smaller startups in that sort of ecosystem, the practitioners who are writing the code, who are solving the problems, the engineers that are really focused on problem, like the thing in front of them, have a lot more latitude on picking the tools they want to use. And that has driven a lot of how open looks and works in the technology space that is just unparalleled in the BAS space.
Got it. Okay. Yeah, there's a lot there.
Yeah, that was a very rambling answer. I'm sorry.
I think what I heard from you, if I could repeat it back, it's myth number one is there is no overarching definition, because it depends on what you're trying to accomplish. It depends on what you want out of your given project or your given building. I think number two is there seems like there's a myth around, and maybe this is coming from the incumbent vendors when they purport it, but I think that I'm seeing incumbent vendors saying you shouldn't want open because what we're providing is interoperability. And so it seems like there's these two, like open versus interoperability might be some confusion. And so I wonder if that's a place to take this next, which would be like, what are the differences between those two words? And like, why would you want open versus interoperable?
Yeah, and I think this goes both ways. You can have systems that are interoperable that aren't open, and you can have systems that are open that are not interoperable.
Mm-hmm.
And both situations can be very frustrating when you're trying to solve real world problems. I guess from my perspective, the interoperable thing is what Bacnet has done for the most part. And it's great, right? Being interoperable, we all need that. That's all like version 0.0.1 of what we're looking for when we talk about this, future of smart buildings.
Just like getting the data flowing, basically.
Yeah. And you start taking interoperable up the stack, it gets a little more complicated. But yeah, Bacnet at the lowest level is solving that interoperability in a lot of ways. Certainly the way we use Voltron, we use Bacnet as an interoperable layer. The open becomes, I bought a thing and it does X. A month from now, my tenants have completely changed. Their requirements have completely changed. And I really need thing A to do Y and Z and not X anymore. How do I do that? Am I limited? Do I have to go back to the initial vendor? Do I have to go back to someone who is qualified or authorized to work on that initial vendor's equipment? How can I take over? And when you said that like the myth is that there isn't a definition, I think what I really am trying to say is that the definition of open is personal. It's a very intimate thing. My definition of open may end up being very different than your definition. And it does factor in all those things that I care about versus the things you care about. At the end of the day, the sort of sniff test that I say is, can you accomplish what you want to accomplish with what you have without involving other folks? And is that a thing that, is going to be really expensive? I think when you talk about Johnson defining open with OpenBlue, the question that we should all ask ourselves is like, how has that worked with other platforms Johnson's released in the past? Mm-hmm. Have we felt like they were future proof? Can we add things onto them? And I don't think you'll find a lot of people arguing that everything was great with previous versions of Johnson's platforms. So
yeah, see Friendly Rant Volume 5.
There you go. I think it really gets down to choice and being able to make those choices, being able to reuse assets that you've invested in. And that really gets down like, is it yours? Did you really buy the thing, or are you just using someone else's thing and you got to beg or pay if you want it to do something different?
Okay, so there's this whole, it seems like two separate questions, interoperability, open. And the way I heard you also is like there's this whole other question around open source as well. So what's the difference there? And how do you think about that?
So I think open source is a tool that the technology industry has used to ensure open systems.
Okay.
So when we say something like Voltron is open source, that means that anyone who's using Voltron, whether they're just going out and getting Voltron off of GitHub and running it themselves on their hardware or whatever, or they're paying us to run Voltron for them with managed hardware. If any of our customers want to fire us, it's trivial for them to do so. Like if we quit providing value, it's trivial for them to fire us. They have a platform that is running Voltron. The source code for Voltron is available. It is written in Python. They can hire any general development agency who understands modern language ecosystem to modify, change that installation, change that deployment to their needs. They have 100% control. So you see this a lot, that like even the companies in the technology space, there's this open source business model that has pros and cons and is under some controversy in that space as well. But at the end of the day, you've got folks who are saying, look, I like what you've done as a technology. I don't mind paying you to manage or help us get the most value out of that technology. So we're going to sign a multi-year service agreement, but that core technology needs to be open source so that I know if you go away next year, or if you get acquired by Oracle or whoever, and they suddenly decide to increase the licensing cost by X or increase the service cost, we can still self-actualize. And that self-actualization is the part that I just don't think exists in this industry at all. whenever I have conversations, it's been a little bit frustrating, I would say. I mean, once you figure out why the case is and dig into it, it makes sense. But we had a lot of problems early on. We would talk to customers about Voltron, and there would always be this like, well, can Voltron do X? And it's sure. Can Voltron do Y? Yeah, sure. And the answer is Voltron can do anything if there's a business case that provides enough value for either you to pay or me to see the potential, like you're going to generate enough deployments that it's going to be worth it for us to build it for you.
Right.
And once we build it, that can go back into the ecosystem and everyone can have that capability. But the answer is always yes. Whereas in this space, people just aren't used to that. They're always limited by what the vendor says is possible. And when you move away from that paradigm, you get to really spend a lot more time working on what does my customer need? How do I build it? And if maybe it costs more to do with an open source tool because I don't get certain starting points, but I know that as my customers' needs change, I can modify and change that to fit their needs without worrying about whether my vision of what I want to do for my customers aligns with what my vendor's vision for what they want to do for their customers develops.
Got it. Okay. Let's dive into a bunch of different levels of the stack here. So you're laughing because this can get hairy, but the reason I want to do it is because I feel like there are different ways that systems cannot be open depending on what level you're at. And I think it'd be good to just walk through, maybe we try to keep each one brief and try to get through each level. What about like at the very edge? You have sensor controller, just start there. And what does open mean at that level?
Yeah. So I think, again, this gets back to how deep you want to go and a very different perspective between this space and I would say the edge stuff closely aligns with modern IoT development. So we think about, IoT systems. For this space, I think the definition of open is, can I reprogram my edge devices? Do I have to buy special software to change controller routines? Those sorts, can I do that without contact? That's the definition of open currently. And I think it's even rare, right? There's not a lot of edge platforms that allow you to do that sort of thing. When we move over to IoT systems, we dive into the hardware a little bit and start talking about what kind of chipset is running that controller. Can we flash a different firmware if we wanted to? And those kinds of definitions that are a little bit outside the scope of this industry for all practical purposes, at least at this point.
Yeah.
But I think the trends happening in that space, there's things like open source CPU instruction sets, which means that now, whether you're a big proprietary vendor or you're just a small startup who wants to build an open controller of some sort, you can build those edge devices without paying licensing fees for the CPU architecture, which all of the devices you're deploying have that built in right now. Like you don't see it, it's completely transparent to you, but ARM is getting a licensing fee, or one of the other technology companies that offers these microprocessor instruction sets is getting a licensing fee. So you have open happening in that space. You have standardization and interoperability at that level. A lot of the sensors now are, I think when you had Deepinder from 75F1, he talked about using digital sensors. And I think probably he should have spent a little more time explaining what he meant, because I'm not sure that this audience can appreciate that. But when he says that, what he means is that the chips themselves that are doing the temperature sensing, the humidity, et cetera, they're not putting out a 0 to 10 volt value. They're not putting out a 4 to 20 milliamp value. They are speaking a digital language with floating point precision over a bus that is local to that device. And in that area, it's funny because all those sensors are interoperable. They're all using a technology generally called I2C, which allows you to daisy chain these sensors on a microprocessor. And so the proprietary layer gets added in the software at a layer above that when we talk about some of these sensors not being interoperable. When he says all the sensors are digital, he means it. And he means it all the way to, at some point, there's probably some physical interaction of material that's being measured, but it's all happening within a piece of silicone, a single chip.
All right.
And I think that like that openness and that enablement of the IoT industry development is democratizing access to deploying and designing these systems. There's a guy in California who had a presentation at AHR this year, Calvin Slater, and he built his own BAS controller, designed it in what's called like ECAD software for designing electronics, sourced the microprocessor, sourced the sensor, sourced the inputs, had the board printed, the PCB printed, and had a working example. And the fact that you can do that, you don't need to be a billion-dollar company to build your own edge device, I think is a huge change that will have an effect on this industry. It's not having, I don't think it's having much of an effect right now, but I think it'll have a huge effect. And that's the open hardware kind of point. And Alper Özmezler, his technology that he's been working on, where he's really trying to build a open platform controller that, you know, essentially he has his software layer that can run on it, but it is an open device that you could run any software you wanted to write and have run on that controller. So I think those are the places where we're seeing transformation at the hardware and edge layer.
Okay, got it. So how about, okay, now controllers are now talking to each other, and that's where we have Bacnet. So help me understand the different, like, how can Bacnet be closed? And let's just assume that everyone understands like where Bacnet plays. And I think everyone kind of thinks that opens things up, but like the way I understand it is that can actually close things down. You can still close things down, but you use Bacnet.
Yeah, you can still close things. I think so. So I think this gets back to that difference I mentioned earlier about how technology choices are made in this space versus in the broader technology community. And the reason why is that a lot of things here, like Bacnet is a standard that's driven by a standards organization, right? The folks who participate on those standards committees, while they're generally open committees, like who has time to actually do that? It's people being paid from large vendors to represent that vendor's interest. So when you look at something that is 100%, I love standards. Standards are great. Standards should exist. And we should be working on more and better standards, even though it ends up with us having one more standard. We still obviously haven't reached the end-all be-all standard. But the thing with standards is when you have all those large incumbent vendors represented so well on those committees, it means that the standard becomes a least common denominator in almost all instances. So where a small open ecosystem of practitioners can say, this is what it needs to do, and it needs to do this, and it needs to be opinionated about these things, when the people involved in making the standard have the self-interest of these large vendors that they have to take into account. They may be great individuals, but at the end of the day, like they can't support and build a standard that obsoletes half their equipment. Like it just isn't going to work. So when you look at Bacnet, for instance, Bacnet is extensible. And this is where we found the most difficulty with Bacnet not really being an open platform. So Bacnet's extensible, which is great. But what it means is that in a lot of cases, the vision for how Bacnet would work and how it would be the interoperable layer for a building didn't match a vendor's technology stack. There wasn't a place in the stack for that particular layer. And so they used proprietary extensions in Bacnet to enable a previous architecture that they had already standardized on. And so you find these instances where they have these extensions that they are proprietary, they are not part of the Bacnet standard, and they are part of the standard, and the standard says you can have these extensions, but they don't fit the architecture model that Bacnet was written for. So you suddenly have like key things that the building is doing that should be done in the Bacnet, general communications model, and you should have access to it, and it's happening behind a closed curtain. And so that can be a problem with Bacnet. I don't know. That's one of those things that's definitely my stance is not, well, don't use Bacnet because Bacnet has this problem. It's, hey, vendors, like worry about actually being interoperable at a level that allows your clients to drive value out of your system.
I see. Okay. All right. So now we're moving up a little bit. So we have device layer controllers. Maybe we're getting to supervisory controllers. We're talking open Bacnet. So now we have a control system, basically. Let's forget the server layer, forget software right now. We have a control system now. The way I understand it is there's a ton of more ways to then lock a system down. So we're talking about all the programming, graphics, application like that you're using to do the programming. You're using different tools that you're plugging in. So like, how do you think about all of those different ways to make it less open once you have a control system.
Yeah. I think an interesting insight into this is that we've actually not worked with it directly. We've done some work with a fairly large vendor's platform that has an API for the platform, right? So this is at the supervisory layer.
Okay.
They have their own API that is standards compliant. It's fairly open. It's a little dated. It works. And this was being discussed in a forum the other day, and people that deployed and knew that system didn't even know that API existed because it wasn't marketed to most of their customers. So I think that in that space, like if you've got a building and as a controls vendor and you have it working under your proprietary system, there's not a lot of incentive to open it. And even if you have the capability of making it open, you may not advertise it, or you may not put a lot of effort into letting your clients. So there's just obfuscation is one layer. Certainly what we find is even if they do have an API, every vendor's API is different. And so now you're talking about the cost to build a product. If we're stepping up a layer to say, we're a company building a product for customers who have these technologies deployed. Now you've got much higher cost to build your product because you've got to re-implement it for all these different API models. And that's the ones that do have APIs, right? And not all of them do. Some of them are completely closed off. Or in the case of, I think when you and Joe Amador had your conversation, that was an semi-open. It was an ecosystem that wasn't open. It was definitely a walled garden that he had worked on all those years ago, but there was a cost, right? You couldn't just build on top of it. You had to be a partner. You had to basically guarantee you were building for that platform and not for, anyone.
Okay. Yeah, maybe when we get a little higher up for the platform. What about all these different ways to lock down at that level? Because isn't there still, okay, you might have an API and you didn't know about it, but isn't there still like ways to lock people in around like software licenses for the specific programming tools and all of that? Like there's like 20 different ways right there, isn't there?
Yeah, and we see some systems where even ones that claim to be open, where they're using a programming language that only they use. And while you may be able to use that programming language for free, somebody's got to learn it. You've got to pay some cost. You got to find that workforce. So obviously, if you have to buy the tools that enable you to work with that technology, that's another way. A lot of it is just locked down to protected vendor relationships. So you've got to be a distributor of this vendor to have access to these tools that take that self-actualization that I talked about away from the end customer.
Yeah.
And I think the other side of that is when we talk about this, in general, the feedback you hear is like the end customer doesn't care. The end customer doesn't have anyone who could do that, et cetera. But I think it depends. I think we're seeing that change. I think that we're working with some clients who do care and do invest and do have teams of people who work on this and are asking the questions of, we can hire app developers to build an app for our tenants, but we can't just hire developers to build new operating systems for our buildings or et cetera.
Right.
So I think we're seeing that being driven at the larger scale by companies, by operators, facility operators who are becoming more sophisticated about how they view the problem space. On the lower end, I think that largely you're right, but this gets back to, is this open ecosystem just a technology tool that will allow you to solve a problem? Or is it an ecosystem that change in market and change how solutions are delivered and change how rapidly you can deploy and change the value you can deliver to your customer? Because at the end of the day, those customers do start to care when it starts impacting comfort. It starts impacting energy utilization, probably comfort more than energy utilization. Things like Local Law 97 in New York are going to start really changing that conversation for much of the industry when you have straight up bottom line cost to an inefficient building. You're paying carbon offsets. So I think then the people who are servicing those smaller customers who don't have those resources, they're going to have to start competing on, we can reduce your carbon tax for your building. Yeah, you only have one building. It's 50,000 square feet, 100,000, whatever the cutoff is. But, we can save you X a year on your carbon footprint. that's when you start to see that, okay, that'll help drive some of these applications with the smaller markets.
Yeah, I've been thinking of it as like leveling up. Like building owners and building operators are being asked to level up in many different ways right now. Like one of them is all these ordinances and local laws. The other one is with COVID, like being asked to level up to entice people back to the building or to keep them safe if they need to be there. And the way I think about it is like the requirements of our systems are going up and up along with the owners being asked to
Absolutely.
level up. And so I think that's going to continue to drive, like if the system doesn't perform and the reason is because it's not open, it'll start to take care of itself. But like you said today, in many ways, we're not there.
And I think another thing that came from your discussion with 75F is they're sending out these stickers that say, we're monitoring and we know our air changes are like, people are actually asking, it's the same stuff. Some of it is even if you didn't have new ASHRAE guidelines, even if you just had the old guidelines, you got people asking questions about whether they're actually happening or not, which I think is a really good force for this industry.
Got it. Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview. Let's talk about platforms then. So as we continue to go up the stack, so I think what you just alluded to was like one type of platform versus the other. Maybe I need you to repeat it back to me, but like you're saying one type of marketplace or one type of platform has the ability to transform the industry. Another has the ability to keep us in the same place. Is that kind of what you meant by that? And how would that work?
Yeah. So I think, again, I've referenced this, I didn't mention by name, your conversation with Deb from Switch, where she talked about we all have this vision of what we think smart buildings should be. And when we talk about that, there seems to be such a gulf between where we are now and what our vision is. And closed ecosystems mean that the way we cross that gulf is like brick by brick, just building one brick at a time, waiting, and there'll be 10 bridges across the Gulf. There's 10 vendors and they're all putting their bricks in. They're all doing iterative releases. They're all like trying to extract as much value from their market at each, every time they lay a brick, they want to get as much money for that particular brick as they can. When we talk about open ecosystems and getting really to where individual contributors, and whether that's like engineers like Calvin Slater who are just working on their day job, deploying, managing, programming BAS systems, and then going home at night and building an entire controller, like who knows, that could be the connective tissue that ends up we all surround around and build the bridge across. So when you open up the opportunity for more people to lay bricks and more people to choose different ways, I don't know, have you ever looked at slime molds? Okay, so there's this really interesting property of slime molds that if you lay out a map of the United States and you put food resources in all the major cities and let a slime mold loose on it, it will build the interstate system.
Wow.
It will figure out where the resources are. And this is, I guess it's an organism made up of a bunch of single-celled organisms or whatever. And it solves that problem by just covering the map, finding all the resources, and then reinforcing the routes that you need to move the resources along that are the most efficient. Right now, we're just, again, we've got a traveling salesman problem where we're waiting on these vendors to travel to all the cities and figure it out for us, when we really need as many hands, as many eyes, as many people as possible working on these problems. And the way we do that is we start unlocking and allowing more folks to have access and accessibility to the solution space.
Okay. Beautiful.
It really is. It's honestly like one of the coolest things I've ever seen in nature is this distributed. And I think that when we talk about open source and technology, that's what you're doing. You're saying, hey, everybody has problems. Everybody has ways they would like to solve those problems. Maybe it's not an equal playing field for everyone, but you're at least welcome to submit your solution. And if it works and it resonates with the ecosystem, it'll be part of the solution. That's it. Like that's the bar. It's not, you've got to go be a Johnson partner. You've got to go be a Siemens authorized reseller. No, you have a solution. You're able to deploy it. You're able to prove it works. The most important thing is proving it works, and the entire community benefits.
Yeah, so it's really about the reusability of the bricks, right? So you're not building it for one ecosystem or one building even. You're able
Right.
to build it once, somebody builds it once, proves it works, deploys it across all the similar buildings and applications
That's
elsewhere.
right. Exactly. That's exactly. If you look at the development of Voltron over the last 5 years, 6 years, whenever it was initially released by the national labs, all kinds of components in Voltron now that were not developed by PNNL, that were, not part of the original solution. But someone
Okay.
came along, they said, "Hey, this is great. It does X, Y. I really need Z. So I'm going to build Z. By the way, hey, anybody else that needs Z, you can use Z too." And that's how we've done that. We've taken technologies that our customers have said, "Hey, we need to do X." And we go, "Okay, that'll take a little time. We'll have to go build that." We go build it. We release it back into the ecosystem. So anyone else who wants to go solve that same problem
Mm-hmm.
has the toolkit and doesn't have to, reinvent that wheel.
Got it. Okay. So how about the types of platforms that are one level up from Voltron? So Voltron's like freeing the data up and providing edge to cloud. Let's pull the data out of existing systems and do cool stuff with it, send it wherever you want, basically. And I'm sorry if I'm paraphrasing and skipping over a lot of Voltron details. We'll get to them in a second. But when you get up to, like, we've talked about OpenBlue, so that's one type of platform, right? When you get up to that level where you're providing applications to users, what can we require from those vendors when we're selecting them, if we're a building owner, that would promote this sort of openness and market transformation rather than, I think, what we're describing as more of a closed ecosystem? How can we create requirements around if we're selecting platforms like that?
Yeah, I think there's a lot of nuance here, because I think in general, the answer most folks will give you is we've got an API, it's open. And I
Mm-hmm.
think honestly, as an industry, we don't have great standards yet that allow us to push back. We don't really have a
Yeah.
lot of good footing to push back and say, you've got an API, but it's not good enough. But I think as you look at things like ASHRAE 223 that are developing right now, and that will, I think, emerge, and the Google Buildings platform that was just released, I think those are the tools we need. They may not be the end all be all solutions, but they're the tools we need to really have a robust conversation. I look at it, a lot of the problems I see with APIs that we encounter at that platform level are, do they even attempt to meet any standard at all? So APIs by default just are very domain specific. It's very hard to standardize on a particular model that is universal without kind of leaning into an enterprise approach that might not be as flexible or as easy to integrate with as you would really like.
Mm-hmm.
So when we talk about that, there's things like OpenAPI 3.0, which is a specification specifically just for how the API works, less about what's possible in the API, more about, is there a specific expectation of how that API should work that is going to be universal across well-constructed APIs. Previously, you would see things like SOAP, which are very much the same thing, not specifying what the API does. It's not domain specific, but it is a way to interact with that API that is standardized, that if you have this type of value, you can read it this kind of way. When we talk about capabilities, I think this goes back to that sort of personal relationship with open, but I would say that the challenge is not just, can it do what I need it to do today? It's, can it do what I need it to do to get to that future we talked about? Because part of that whole consumer pain distance is time. We buy a new phone, I buy a new phone, I try to control myself to keep it to every 2 or 3 years. A lot of people buy a new phone every year. So that feedback loop is much more rapid. When we talk about buying building systems, we're talking about 10, 15, 20-year cycles. So you've got to think, when you make your decision, you got to think in a 15-year cycle. And I'm not saying we're going to have buildings that are as smart as we really want them in 15 years. I would love to think that, but I just, not sure that's realistic at this point. You should be thinking, what I'm buying today, what I'm deploying today, what I'm investing my time to learn, those kinds of resources, is it going to get me all the way? Is it going to still be of value in 10 years? Is everything I learned about, Johnson's proprietary communication protocol from their edge devices from 15 years ago, is it still valuable today? Or are there other things that have supplanted it that I really should be thinking about? What's the thing that's most universal or that I can iterate on myself?
Yeah.
Those sorts of questions, I think. So I think like what we have to do as an industry is when we think about that vision we all have of what a smart building is, how we would interact with it, what are those individual granular things that your systems need to be capable of? And do you have a roadmap for how what you're deploying today is going to accomplish that?
Yeah.
Do you understand when a user says whatever preference they put in their cell phone app and X happens in the space, can that happen? Do you have the ability to control those things? Are those actuators even installed in your system? Those are the kinds of questions we need to be asking today. And I think that gets back to when you start talking about the platforms, it's, can I do like individual room control through this platform? Can I do these set point, setbacks at an individual user level? Those are the kinds of questions that when you look at an API, not just, I think from a technologist perspective, I would look a lot at like, how does the API work? Is it, similar to other APIs, that sort of thing. But the individual capabilities are all based on those use cases that you have for your clients.
Got it. And from a platform selection perspective, is this ecosystem, it's just like the API, can the API do it? But then from the roadmap of that platform as well, is the roadmap of that platform over the next 10, 15 years, is it going to go where we need to go as well? So interesting. That leads perfectly into the workforce question. So when I think about the stack we've been walking up, we've been walking from a sensor all the way up to some sort of platform with the user interface. And then of course there's the user, but really I think also there's been users throughout the entire stack. So there's been people that have been setting up these tools throughout this whole entire stack. So how do you think about the workforce and everyone skilling up and our supposed shortage in skilled workers in our industry with the proprietary versus open question? Am I understanding your thoughts around it being the more open it is, the less of a workforce problem we have?
Yeah, I think yes, but there are some very specific ways that's true. So the workforce thing I find really interesting because basically as long as I've been deep into this on the smart building side with ACE IoT, everyone's saying, look, we've got this aging workforce. Our pipeline is empty. We're not putting people into these programs. But then you see them defending keeping everything vertically integrated. The same people who are saying we don't have enough people are also saying there's only one true way to be in this industry, and you've got to come through. You've got to be an HVAC tech that upskills into an automation tech, blah, blah, blah. Or you got to be an electrician who becomes a controls tech, who then becomes a BAS programmer. What I see is we're making all these choices on the technologies that are non-standard. They're not what the rest of the industry, the rest of the technology industry is using. Like when you look at Haystack is great. Haystack is so much better than anything that's been before. But you look at like the Haystack API definition, and it uses a data format that no one, like it was invented for Haystack. Wow. And no one outside of Haystack ecosystem is using that. So when you start talking about where do I hire people, if I have a great idea and I want to build a company, can I just go hire software engineers? Maybe, but you're going to have to spend some money upskilling them with these like very specific ecosystem skills that the rest of the technology world isn't paying that tax. Like they're all using the same stuff. They're all using the same kinds of data formats. So those kinds of questions, I think, when I look at, well, where is this pool? Like I'm involved in my community quite a bit. I have good relationships with our community college. I talk to them about some of this stuff. People aren't just flooding into their HVAC programs. Like even with all this data and all the effort that's been done on the marketing of that particular career path, people aren't just flooding into there, but people are flooding into data science programs. They're flooding into Python or full stack web development. So why aren't we as an industry figuring out how to make those skills more valuable or at least lower the impedance of people coming from those kinds of programs into this industry? 90%, this is one of those things that is kind of a hard truth in the data science world, but like 90% of the data science work is wrangling CSVs around. Like it's like very simple stuff, and it's stuff that this industry has. It's problems this industry has, but because this industry is so vertically walled garden structured, it's very hard for someone to just come into the industry from that perspective. Like there's this expectation that they know all these proprietary tools, that the only way to know those proprietary tools is to already be in the industry. And I'm not saying that the solution to all of our workforce problems is to have more developers like turning screwdrivers. That's not what I'm saying at all. But what I am saying is that it seems like we could get a much wider pipeline if we were focused on using and building tools that sort of build off what the broader technology industry is doing. Because I think this is an interesting space. And I talk to people every day who paid that tax, who did that extra work to move from technology into this space. And they did it because they care about things like the environment. They want to make an impact on CO2 emissions or greenhouse gases. Like it's those kind of people. So that's possible. It's just that we make it hard. You have to really want to do it. And I just think that there are a lot of choices we make on a day-to-day basis on the technologies we deploy that could simplify that and make it not quite such a hard problem.
Love it. So one of the things that I love about your LinkedIn posts, Andrew, is you're often bringing in other industries and how our industry is behind those, and they've gone through the same progression from closed to open. So can you give us a few like examples? And I'm going to expose my ignorance here, but one of the ones you put on LinkedIn was Kuber something. And Kubernetes. So I didn't even know how to pronounce it. So like, what would be some examples of other industries that you think would be good for people to study up on?
Yeah. And I think I specifically was using Kubernetes. I think this is worth talking about. And so there's probably other examples, but I'll go a little deep into this,
Cool.
Hopefully not too long. But so Kubernetes is really interesting. I was using that as an example of how open source can be a market transformation tool. Okay. So if you look at 8 or 10 years ago, there was Amazon Web Services, maybe not even 8 or 10 years ago. This could have been as recently as 6 or 7. You had Azure just getting started up, but obviously it could eat a lot of market share just because people are going to go with Microsoft because they already had on-prem deployment. And then you had Google Cloud. And Google Cloud, like Google undeniably runs some of the largest systems in the world. They're the best at running these larger systems, but they weren't very customer focused and they didn't have a very good connection. Like it's very hard to meet Google where Google is at. And that's one of the reasons why we see solutions, that there is a lot of work to taking solutions from the technology space and moving them into the BAS space, is because some of these solutions are coming from companies that have 100,000 engineers working on these problems. So like their solution is going to be at such a level of complexity to solve their global problem that it's very hard for smaller entities to reason about how that works. But they took a technology that they were using internally for running all their services, the stuff like Gmail that you use every day, and kind of rewrote it to be more accessible to folks who weren't running Google, but it did simplify running and managing web applications at scale. And scale could be tens of servers or maybe hundreds of servers. And their incentive for doing so was that they knew more about that system than anyone else, and their cloud platform was better oriented around that system than anyone else's. So they gave away this technology for free. They started an ecosystem. They supported that ecosystem. They invested their engineers' time in supporting an open source ecosystem. And in return, they got huge market share. Tons of people who were frustrated. The developer communities in these organizations are very different from the operators of the IT infrastructure. And they were frustrated with things like getting databases provisioned on their proprietary database clusters or getting VMs provisioned. And so they would say, let's just spin up our own little Kubernetes cluster and then we can run our applications and iterate quickly and bypass all that process. And then what do you know? 1% of those applications are successful, need to scale up, need to move into a cloud infrastructure. And hey, Google's got the best place to do that. So this, I think, also feeds into the comment you made very recently, which is stickiness versus, proprietary. And that's exactly what it was. It was generating a technology that solved an acute pain in the community and solved it in an approachable, accessible way that then had an on-road to, if you need to solve this pain now and you grow, once you get to a point where there's enough value for you to be a useful customer, then we have the platform that continues to solve that pain for you and does it in the ways that you're familiar with. And you won't have to re-architect your application. You won't have to hire additional operations folks because it's just going to work the same way it worked throughout the development process.
Interesting. Well, that's fascinating. I feel like I could absorb these analogies from other industries all day because it feeds my soul, like knowing that other people have gone through these same issues and it's worked out in the end. So what are a few others that come to mind besides Kubernetes? Is that right? Did I say it
Yeah,
right?
I think one of the big ones, and I've been trying to define and help maybe just clear up some of these perceptions of open and open source from this industry sector. And I think when I say open and open source, not always is open source the best. Like it's not always the right answer. You can make choices that open sources might be capable of doing something, but may be focusing you and your company on the wrong value stream, that you need to focus on something else. And there's a proprietary solution that allows you to move your focus to the thing that you care about. So that happens a lot. But I think another example that's sort of like Google, but in almost an opposite end result. So this can go good or bad, I guess, is what I would say here. This is like a cautionary tale as well. But MongoDB kind of went through that exact same cycle. So a lot of people have heard of MongoDB. It was almost exactly the same pain solution. Was I can't get DBs deployed. I've got to hire a database administrator just to help me understand how to write an effective schema for this Oracle database solution I have. These are the problems that were happening in large enterprises. So Mongo came in and said, hey, you don't have to worry about schema. Like you just build your thing and it'll work. What they didn't tell anybody was it would work up to a certain scale and then you might have problems, but they were available for you to pay them to solve that problem. And so now when you look across enterprise, like MongoDB made a ton of money off enterprises because a small software team in enterprise would start building a solution for some business problem with Mongo, and then it would turn out to work okay. And they would need to scale it up across the enterprise. And now all of a sudden they need help. And so you've got, oh, if you pay for our commercial license version, we solve these problems for you that aren't solved in the open source version. So you have to like buyer beware on open, like even if you're not buying, you still need to be aware of what you might be buying into. And, you know, in the technology world, we have this saying of like open source is there is free as in puppies. So like a free puppy is anything but free, right?
Absolutely.
Like,
yeah.
We've probably all been in that situation. So I try to be objective about this stuff. So to give you both sides of that story. One side, you know, you've got Kubernetes that solves a huge problem for you. Like at this point, Kubernetes is available on all the other cloud platforms. So if you want to run it in Azure, you want to run it on AWS, they have Kubernetes product solutions as well. But Mongo is a little different system and a different kind of approach. And they end up with a different way of same kind of lock-in, but the investment up front is free.
Got it. Okay. All right, let's bring it back. So we mentioned the people on LinkedIn phoning in their questions. So one of them, and apparently could be a little bit of controversy around this, but let's circle back to some of these questions in the end here. So they were asking about individual companies as an example. And so one of them that I want to ask you about for sure is maybe summarizing all that we've talked about so far, which would be like, where is Niagara closed and open, and how do you think about that company specifically? Because I think the perception would be that Niagara is fully open, and that's at least my perception of how people think about it. But is that true, and how do you think about it?
I think this goes back to what your previous question of asking for examples, and this question, we can merge those because this is like a perfect opportunity to compare and contrast about what my expectations, my personal expectations of what open is versus what something like Niagara provides you. And I'll get very specific on both sides just so we can have clear talking points. I'll talk about Niagara as a programming framework and language and tool. And then I'll talk about Voltron and Python as a programming language and framework and tool.
Okay.
And just compare. So like with Voltron, who do I pay to run Voltron on a device? No one. If I want to write Python code that runs inside Voltron, what tool do I need to use to write that or compile it or, you know, package it to be distributed? A text editor. So literally like anything. What hardware can I run Voltron on? any hardware. I don't need like a sticker that says license for Voltron or license for Python. So those are the expectations I bring when I look at things and ask if they're open. And under that, I think it'd be pretty hard to argue that Niagara, falls into any of those expectations. But I'm not here to like make a concrete judgment on whether something is open or not. I'm just telling you from my perspective what I look at.
Yeah.
And I think that you look at something like SkySpark, it's very similar. And I think that model works great. It obviously has been great, but I also think the real test is how long has Niagara been in the market, and do we have that smart building future that Deb talked about that we all aspire to? And so if we
I think the answer is
don't,
no. Yeah.
if we don't, then something needs to change. And maybe it's not Niagara's fault. Maybe it's how it's being used. Maybe there's all kinds of ways to talk about it. But I don't think no one's saying the buildings are as good as they need to be. But then you do find people defending the tools that are used to make buildings the way they are.
I totally agree. 100%.
You can't separate those two. There's either things are as good as they need to be, or we can improve what is. And I think we can improve what it is.
And that's the journey I'm on. And honestly, sometimes I get direct messages or emails that are giving me flack because it's like, why are you promoting these new companies, or why are you giving a platform to these new companies? And my answer is always, we haven't solved it yet. And we need to keep looking because the problem still exists. And as soon as the problem is actually solved by one of the companies, I'll give up. I'll go play golf or something. But like my pursuit is around like finding the answers. And I think we're still looking at, like, just like you said about what Deb said, is we're still trying to realize that vision, and it's still out there. So, okay. So I love that answer. As we close this out, let's talk a little bit about Voltron. How are you using it today is my first question. And then like, where do you see the tool going, and where do you see the platform headed is the second?
I'm going to answer that backwards. I'm going to talk about the vision that Voltron was built with, because I think it's important to understand where it came from. So Voltron was a tool built for researchers by researchers in the National Lab System to solve the problem of having a platform where they could build, test, simulate, and really review new paradigms for grid operations. So specifically a concept called transactional energy. So the idea that everything that's consuming or producing energy participates in an open market. Your chiller is negotiating with your building for energy. Your zones are negotiating with your chiller for energy, and they all have some price they're willing to pay. So you can optimize. You don't need schedules if you don't need like hard schedules. If your schedule is, I'm willing to pay this much during this time of the day and this much during this time of the day for conditioned air, and every asset can speak that value, right? Like they all have that as a universal. Right. And you could do it with just saying KWH or KW or whatever as well. But this was the vision that like that translates all the way up from your computer, monitor staying on all the way to grid scale is a negotiation. Got it. So Voltron was built to allow the national labs to build out test systems that really showed off that transactional. So it needed to be able to communicate with building systems. It needed to be able to communicate with IoT systems. It needed to be able to communicate with grid operation systems, switchgear, that level, generators, microgrid, inverters, solar inverters, that sort of thing. And it needed to be able to communicate both ways. So we talk about Voltron a lot in like this data platform layer, but it fully supports communications in both directions. So you can use it for writing values, for pushing set points, for doing all the things you would use a supervisory control system for. Now, to get back to like how we use it, I think we're squarely right now in, I would say our primary use case that our customers bring to us is in advanced supervisory control 1.0, where we're bringing back a bunch of stuff. We're allowing them to run analysis. We're allowing them to look at the data in depth, map, do all their tagging, all that functionality so that they get real insights from their equipment in real time. We are starting, and when I talked about that EPRI project with the residential loads, that's where we're starting to get into, and we're working with a couple of other platforms that are more on the building side, but getting into the advanced supervisory control 2.0, where we can start pushing things. Control is happening at that layer. We're enabling other applications to optimize specific parts of the system So we can, by using Voltron as this meta layer or middleware, we can farm out the parts of the system that are most effectively optimized by various components and give you choice on what you use for which part. So you're not buying into a particular optimization vendor's ecosystem for your entire system or your entire portfolio. You can say, this building, this technology really works well in this building, but this is a different type of HVAC system, and it works better with this kind of optimization. So you get that sort of ability to really it gets back to choice, which is where I think open, if you made me give you the one word answer for open, it's choice. It's, do you have choice? We use Voltron to give our customers choice about how they optimize or how they use their equipment or build advanced control solutions.
Got it. I love that. And yeah, let's do this conversation again sometime, because I really want to get into the value of that independent data layer. I think that's just as controversial with some of these companies that would rather provide a full stack. And so I think that's another area where we could get into the weeds. And with advanced supervisory control, I've been having so many conversations lately where people are skeptical that's even a real solution and that the market wants that. Specifically, like our building owners wanting that. So I really want to get into that with you in the next conversation. But for now, we should close this down. I think we could go all day. And I just want to thank you for coming on the show. Also, thank you for listening to all the past episodes. I feel like that really helped get us on the same page for this one. So I really appreciate the time you put in there and all the knowledge you're dropping. So
all the time you put into that, and also the guest you had. You've had some really great guests. Yeah. So it was time well spent for me. I don't feel like I feel like I got more out of that than you did with this conversation.
Awesome. Let's get another one on the calendar. And thanks a lot, Andrew. And I'll talk to you soon.
All right. Thank you.
All right, friends, thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.